Okay everyone, today we are going to talk about solving inequalities. Previously we use only addition and subtraction and we use only one step. Again we will continue with one step solution, but this time we will use multiplication and division. Before starting solving inequalities, I want to show you some things. There are some comparing numbers. So 3 is less than 5, 4 is greater than negative 7, negative 4 is less than negative 2. So I want to show some things to you. If you multiply both sides with the same number, such as 2 times 3 or 5 times 2, so 6 is less than 5. So we multiply by 2 and it's less than 5. Let's change it. Let's multiply by 3 or let's multiply by 7, no problem. If it's positive, there is no problem. 7 times 3, 21. 5 times 7, 35. Again, 21 is less than 35. This is first. But, if you multiply both sides by a negative number, such as minus 2. If you multiply by minus 2, so negative 2. Negative 2 times 3, negative 6. 5 times negative 2, negative 10. Which one is greater? So negative 6 is greater than negative 10. As you see, the sign changed here. The values change when you multiply by negative. Let's multiply by negative 7 or any negative number you can try. Negative 7. Negative 7 times 3, negative 21. 5 times 7, negative 35. Again, as you see, negative 21 is greater, so sign change. When you multiply by a positive number, the greater or less than sign, the sign didn't change, but here it's changed. It's the values change a bit. Okay, let's see the second example. This time first number is positive, second number is negative. Let's multiply by positive number. Again by 2, no problem. 8 minus 7 times 2 minus 14. As you see, 8 is greater. Any number it can be. Let's multiply by positive 5. So 20 is greater than negative 35. So let's change it. Let's multiply by a negative number. Let's multiply by negative 3. You can choose any number. Negative 3. Negative 3 times 4, negative 12. Negative 7 times negative 3 is positive 21. Negative multiplied by negative is positive. So negative 21, negative 12 is less than positive 21. So again, when you multiply by a negative number, the sign, this sign will change. Now it's greater than. Now it's greater than. But when you multiply by a negative number, both sides, as you see, I'm multiplying same numbers. So when you multiply by negative number with same negative number, it will be less than. It's greater than. It will be less than. You can try lots of negative and positive numbers. You can see the results. Okay, both of them negative now. Let's multiply by a positive 2. So 2 times negative 4. 2 times negative 2. 2 times negative 4, negative 8. Negative 2 times 2, negative 4. And negative 4 is greater than negative 8. Let's multiply by 10. Positive 10. Multiply by positive 10. So 10 times negative 4, negative 40. Negative 2 times 10, negative 20. Again, negative 40 is less than negative 20. Let's multiply by a negative number, such as minus 10. Minus 10. So negative 10 times negative 4, positive 40. Negative 2 times negative 10, 20. So for positive 40 is greater than positive 20. As you see, again you can try lots of negative numbers. Like I can try one more time. Negative 1, negative 1. I will multiply both sides by negative 1. 4, 2. 4 is greater than 2. So you can try lots of negative and positive number and you can decide if the sign will change or not. You can try it. You can stop the video and try it on the screen, no problem. Let's continue new things. These are important to solving inequalities. As you see, when we multiply by negative number, inequality sign changed. So here it's bigger, 15 bigger than 12. Let's divide it this time. Let's use division. Is it same with the division? Divided by 3. Both of them divisible by 3. 15 divided by 3 is 5. 12 divided by 3 is 4. As you see, that was bigger. Now 5 again bigger than 4. Let's divide it by negative 3. Let's divide it by negative 3. Negative 3, negative 3. 15 divided by negative 3 is negative 5. 12 divided by negative 3 is negative 4. As you see, this time negative 4 is greater than negative 5 and the sign changed. You can divide by negative 1 because they are divisible by negative. Both of them divisible by 1. You can try by 3 and by 1. Let's see this example. Negative 20, 28. Let's divide it by 2, both sides. Negative 20 divided by 2, negative 10. 28 divided by 2, 14. And 14 is greater than negative 10. So now let's divide it by negative 4. Both sides, negative 4. Negative divided by negative is positive. 20 divided by 4 is 5. And positive divided by negative is negative. 28 divided by 4 is 7 and 5 is greater than 7. As you see, when you divide both sides by same negative number, inequality sign change. So, sorry, that's okay. Let's see the next one. Both of them negative. Let's divide by 2. If you divide by a positive number, negative 5 is greater than negative 9. This is true. But if you divide it by negative, such as negative 2, let's divide both sides by negative 2, 5 is less than 9. So negative 18 divided by negative 2 is 9, 5 is less than 9. When you multiply or divide by a negative number, both sides of the inequalities by a same negative number, the inequality signs always change. This is very important. When you divide by a negative number or when you multiply by a negative number, both sides of inequalities, inequality signs, sign of inequality will change. That's it. It must change all the time. So why I told that part, this wasn't our topic. As you see, there is an inequalities. 2 times a number must be greater than 8. So there are lots of numbers, infinite numbers, value of x we have here for this inequality on the solution set. But what is it? Let's find. That's one term. There's a coefficient, so 2 multiplied by x. I need to divide both sides by 2. So divided by 2, divided by 2. 2 divided by 2 is 1. So when I divide by positive number, inequality will not change. X is greater than 8 divided by 2, 4. So I divide both sides by 2. Inequality didn't change. Previous examples we saw that one. So x must be bigger than 4. So which numbers are greater than 4? Let's say 0, 1, 2, 3 and 4. This is my checkpoint. It's not include. As you see, there is no equal signs. It's greater than only. So the 4 is my checkpoint. And which numbers are greater than 3 is greater than 4? No. 2 is no. 2.1 is no. 1.5 is not greater than 4. So the left side is not my solution. This side not my solution. Let's check the other side. Is 5 greater than 4? Yes. 6? Yes. 7? Yes. 5.1? Yes. So these all numbers on the right side of the 4, these are my solution. Okay, as you see, 4 is my checkpoint and all numbers on the right side, they are my solution. Let's try. What is my inequalities? 2 times x is greater than 8. Let's check a number. For example, 7. Let's say 7. It's right side of the 4. 2 times 7 is greater than 8. Is that true? It must be true because this is our solution. 7 is in the solution set. So 2 times 7, 14 is greater than 8. So as you see, it's true. Let's choose a number. It's not in the solution set, such as 1. Let's try this one. Let's change. Yes, that's better. Okay. 2 times. Sorry, I couldn't choose black color again. 2 times x is greater than 8, and I will substitute 1 instead of x. 2 times 1 is greater than 8. 2 is greater than 8. Is it true? Wrong. So 1 is not include. It's not in the solution set. Include solution set. In the solution set. It's not in the solution set. It's not a solution. 1 is not a solution, so it's not in the solution set. So let's continue. Negative 3 times x is less than 9. So negative 3 times x is less than 9. So I need to divide both sides. As you see, negative 3 is coefficient here. I need to divide both sides by negative 3. Remember that one. If you divide both sides by a negative number, so negative 3 divided by negative 3, 1. So 1 times x is x. And if because of I divide both sides by a negative number, the inequality sign will change. So 9 divided by negative 3 is negative 3. So x is greater than negative 3. So 0, 1, so minus 1, minus 2, minus 3, minus 4, 1, 2, 3. Where is the negative 3 here? That one, my checkpoint. As you see, negative 3 is not included. There is no or equal sign. So negative 3 is my checkpoint. X is greater than negative 3. Let's use 0. Is 0 greater than negative 3? Is 0 in the solution set? Yes, it is in the solution set. 0 is greater than 2. It's true. So the right side of my checkpoint, negative 3, is the solution set. All these numbers true for the given inequality. Okay, minus 3x is less than 9. So as you see, there is a coefficient. So only one term. There is no constant number. We need to divide by this coefficient. So we have to divide both sides by a negative number. Be careful here. So let's divide by minus 3 and minus 3. So minus 3 divided by minus 3 is 1, and 1 times x is x. So here don't forget, when you divide both sides a negative number, the inequality sign change. So 9 divided by minus 3 is negative 3. X is greater than negative 3. Let's 0 minus 3, put a circle because it's not equal. So greater than minus 3, the right side is true. Why? If you check 0, 0 is greater than negative 3. Be careful here, the important part, when you divide both sides by a negative number, inequality sign change. It was less than, now it's turned to greater than. Okay, another example, x divided by 2 is less than 0. So when you multiply both sides by 2, 2 divided by 2 is 1. So x is less than 0 times 2 is 0. X is less than 0. Let's check that one. 0 is here. So minus 1, 1, minus 2, 2. That's enough, I think. Let's check a number. 0 is our checkpoint. So let's use 1. Is 1 less than 0? No. So 1 is not in the solution set. So we need to go to the left side. Let's check. Is negative 1 when x is negative 1? Negative 1, is it less than 0? Yes. So left side, all numbers on the left side of the 0 is solution set. Negative m divided by 3. So I don't want negative m, I want positive m. Therefore, I need to multiply by a negative number. So I need to multiply by a negative number. But negative what? So as you see, there's a divided by 3. If I multiply by negative 3 both sides, so multiply by negative 3, I can get m. Why? Negative multiplied by negative positive. Negative multiplied by negative is positive. Let's change the color to make it clear. Negative multiplied by negative, it will be positive. 3 divided by 3 here, 1, positive 1. 1 times m, positive m. Here m. Be careful, we multiply both sides by a negative number, so inequality sign will change. It was greater than or equal, now it's less than or equal. 2 times negative 3, negative 6. M is less than or equal negative 6. Let's draw a number line. 0, negative 6, let's say it's here. So empty circle, no, this time there is an or equal, so 6 is included to the solution set. So I need to shade it. Do I have to go to right side or left side? Which side of the number line is solution set, is our solution set? Let's try 0. Is 0 less than negative 6? Wrong. So 0 is not inside the solution set. That means the right side is not our solution set. The left side is the solution set. Let's change the color. Let's make it red. Draw it red. So the left side of our checkpoint is solution set. 15 is less than or equal to 5. If you divide both sides by 5, this is a positive number. So when you divide it by a positive number, we don't change inequality signs. Now 15 divided by 5, 3 is less than or equal. 5 divided by 5, 1. 1 times x is x. 3 is less than or equal to x. So let's see, 0 is here, 3 is here, the right side of the 0. Let's change the color. Okay. 3, is it equal? Yes, it's included to solution set. Let's shade inside this circle. Then let's try. Let's use 0. Is 0, when you substitute instead of x, is 0 greater than or equal to 3? So 3, is it less than or equal to 0? Is 3 less than or equal to 0? No. So 0 is not inside the solution set. So we cannot go left side. We must go to the other side of the 0. Or you can choose any number of the right side. Let's choose a number. Let's say 5. 3, is it less than or equal to 5? Yes, 5 is true. As you see, the right side is true. Last example. Negative 1 is less than or equal to negative 2. I have to divide both sides by negative 2. I want only x. I don't want negative 2. So negative 2, negative 2. So 1 over 2, negative divided by negative, positive. So positive 1 over 2. Sorry, let's write with black color. 1 over 2 is less than or equal x. You can say no. Why it's wrong? Because when you divide both sides by a negative number, inequality sign must change. It was less than, now it's become greater than or equal x. On the number line, 0, 1 over 2, 1. Let's use 1. 1 over 2, is it greater than or equal 1? Wrong. This is wrong. This is my checkpoint. Fill it. Is 1 in the solution set? No. So I cannot go the right side because 1 is wrong. So 2 will be wrong again. 2 is not less than 1 over 2, or 1 over 2 is not greater than 2. I have to go the left side. All the numbers on the left side of 1 over 2 is correct for these inequalities, and 1 over 2 is included. This is the end of the video. Thanks for